Hi, Walter. I thought it might be better to tell you directly our story, a little bit of our story here in Portugal about the water distribution system analysis and about my own experience with this regard. So I'd like to share with you the early steps of hydraulic simulation model here in my country. Then come back to the more mature stage of hydraulic simulation here and talk about the national initiatives that are collaborative projects we have been running for some years now. A little bit of the international activity, because you asked me to share with you what is our has been our work with regard to the International Water Association and some what I call sidewalks. Starting then with the early steps of hydraulic simulation here. So when I was still a student in 4th or 5th grade of university, I joined Linux team. And I started exactly by hydraulic simulation. So Jaime Batista, visionary with his 2 feet on the ground, but a visionary and a transformer. I'd say he transforms societies, he transforms organizations, he transforms institutions for the better. He was starting his PhD student by then, his PhD thesis, sorry. And the topic of his PhD is exactly the optimal design of water distribution systems. And I came to help in this area. So he was starting to work with an open source code from the US that used the Newton-Raphson equations and basically with Asian-Williams friction factor function. And so we developed an application, a Fortran application that we called Simal1, that was used for the first time ever in a Portuguese town, Almada, not far from Lisbon, just the other side of the river. And so this was the first real application for use of the utility people in Portugal. This was back in 81, 82, more or less, 1981, 82. So already a long time ago. Jaime continued to work and develop an optimization algorithm where the cost function, the optimization function was a cost function with constraints that were pressure, velocity, and the hydraulic equilibrium equations. The way it worked was basically it had the optimization process. He was working with a continuous range of diameters, and at the end of the process, then he converted the economic diameters to the commercial existing diameters. This software was very demanding in terms of the time of machine. I believe it was not optimal with that regard, but anyway, we're talking about an area where the computers were very different from what they are now. They are nowadays. And so for big networks, we could easily have hours, many hours, 10 hours, 12 hours, 15 hours of computing time to have a solution. And this program started to be used by the engineers, by the consultants. They used to come here and ask us to run a given network in order to provide them with a basic design that they could then work out and transform in the proper design, so to say. And well, I was young, I was still the student, and of course, when this type of work used to arrive here, I was the one who was, well, selected, so to say, to do the core of this type of work. And I'm lazy. I'm sorry, but I'm really lazy. I don't like to work very much. So I decided to think of a lazy version. And how does this lazy version works? And Jaime ended up with my assistants ended up building it in the Fortran code, and we built together the CMAL2 that basically what it had was the following. It used to start with a first solution, an initial solution that assumed that all the diameters were alike. For instance, 100 millimeters or 200 or whatever. So the same diameters all over. And then we ran the hydraulic engine of the software, and from this hydraulic balance we got a set of flows and velocity of flow velocity in the pipes. Based on that, then we converted these results into the correct diameters based on either a maximum velocity criteria or a maximum unit head loss criteria. We had these two options. And then we chose the commercial diameters that better fit to that first solution. We repeated that in an iterative way, encoded in this application, and in general, with about 4 to 7, 8 iterations, the process used to converge and provide a design solution. So, as I explained, this was to save time, because the optimal design was really very time consuming. But to our surprise, in most situations, the results from this lazy version from CMAL2 were either very similar in terms of the cost, the total cost of the network, very similar in terms of the design, and in some cases, CMAL2 would lead to even less expensive solutions. So this made me think, but only later on during my own thesis, I came back to this issue. I had never forgotten about it and decided to really think of it a little bit more. And I'm telling you that because I believe this, as someone that really likes this type of issue, maybe it's quite logic for you that we have this type of result. For me, it was not obvious, I should say. Now it's completely obvious, but at the time, it was not so obvious why this was happening, why this lazy solution was working. It was kind of intuitive for me, but not obvious why this was the result. Now, well, during the thesis, I worked a little bit on this and tried to understand, and now it's obvious. And what happens is that if you have all the diameters, if the solution 0 is all diameters, equal diameters for all the network, this means that the hydraulic balance will lead to a distribution that corresponds to a minimum energy solution. So the water looks for the shortcuts, for the easiest way in terms of energy. And of course, this corresponds to shorter path this corresponds to lower costs. And so as we are taking in each iteration the benefit of having already the commercial diameters, so this is the reason why CMAL2 led sometimes to cheaper solutions. Well, having finished this parenthesis, so to say, continuing with our road, LENEX started to provide services for the industry with this regard. We built simulation models to assist utilities in their operation and planning studies for many places in Portugal, many cities all over, Barreiro, Pia, Lavradio, Guarda, many of them. And eventually we assisted a Portuguese consulting company, a small consulting company, that was working for Mozambique, for Maputo. They were developing Maputo master plan, the rehabilitation plan. Maputo by then was in a civil war. It was by the end of their civil war. And 1986, 1987, more or less. And I believe you can imagine was, for me at the time, to work in a simulation model for a city I had never visited, for a country and a continent I had never been to. Based on a software that used to produce pages and pages and pages of figures, but not of numbers, but not a single scheme, not a single figure to have an understanding, a graphical understanding of what was coming out. This was prior to the publication of the EPA net and the graphical version of EPA net. And so our CMAL 1, 2, 3 had no graphics at all. And to crown it all, in Maputo, we had, it was a big and complex system, 5 or 6 subsystems, and we had just 3 pressure gauges. You may remember the old paper discs where the pressure was used to be recorded, and we had 3 of these devices to calibrate the whole thing. And the field work was done by the consultant we were working with. He was Portuguese, he lived here, and once a year, twice a year, he used to go to Mozambique for 1 week to collect everything he could collect. So all the story, all the field work had to be concentrated during these days he was there, in an environment of civil war. So you can imagine that this was not exactly a very easy work. So I carried out hundreds of simulations in order to ensure that the trips to Maputo were as effective as possible. So I tried we worked together in order to identify really the issues that might be justifying some strange results we might have in one or other case. So a small short story with this regard that I find, well, kind of unique is that, as I mentioned, we had these 3 extremely valuable pressure gauges. And once the operator who was changing the paper was somewhere in the middle of the street, in a gate or wherever, I don't know, and a soldier approached him and asked him what was he doing. He looked suspicious. And the poor guy apparently was not able to properly explain what he was doing. Maybe he didn't know very well what he was doing, or well, I don't know. The soldier didn't was not convinced with the explanation, so the poor guy went to prison. So he stayed in prison for 1 week, a full week, because he couldn't explain what he was doing. And with that story, we lost 2 of our 3 pressure gauges. So we had 1 left to do the calibration of the whole thing. Well, with all these challenges and stories, what happened is that we really felt the need to produce some kind of synthetic measures that could give us a simple perspective and notion of, well, if a given simulation was really modifying the pressures or velocities or whatever. So we were looking for synthetic performance measures in some way. And this was really the birth of the performance assessment here at LANEC. So this was really motivation by the need that led us working in performance assessment of water distribution networks and well, urban water systems that brought in a later stage. So after this early period, we left to the private consultants to develop, to provide this type of service, to develop simulation models for the utilities. It's part of our policy here at LANEC. You may know that we are an applied research organization. We are a governmental applied research organization, and we don't compete with the private consultants. So what we do is to try to go a step ahead, so to say, and when the type of work that we carry out becomes kind of routine, then we leave it to the market and we move into another direction. And so this was what happened, because in the meantime, EPANet was published, and well, consultants started to offer this type of service, and we simply stepped out. What happened is that, well, 10, 15 years afterwards, what we realized is that all the simulation models that we had developed had been, in the meantime, abandoned. They were no longer being used by the utilities. And the same was happening to the models developed by the the consultants that were on the market. And this made us think, why? Why does this happen? And we realized that the main reason is that because this type of tool, the utilities need to feel confident about how they work. They need to understand how to change them, to customize, to update, and to have a process. Hydraulic simulation it needs to be addressed as a process within the organization, so that it's really sustainable and really works. So based on that type of rationale, we decided to launch a collaborative project in a model that we had tested before with a collaborative project called the PI Waters on performance indicators. And then we started with this INSA, the Sustainable Hydraulic Simulation Initiative, where the utilities develop their own simulation models and build their own process, so to say. So we work with a number of utilities. In this case, I think they were 12 or 15 utilities. We work with them for almost 3 years, and they very successfully build their own simulation models that are, in most cases, evolved a lot and are being used in a very active way. They are connected directly to the GIS systems, to the billing systems, in order to ensure that they keep updated and active. After that, we continued with the use of network analysis and water distribution analysis in the scope of other collaborative projects, such as the IGPI collaborative projects, infrastructure asset management, or IPERDER that has to do with water losses and energy management. I'll come to these two later on. You also asked me to share with you a little bit of our international activity, and particularly with my own international activity, particularly with regard to IWA. Well, the key principle here is that we share, we hear, and we learn. So we always had our doors open, so to say. We really love to share, because we believe that by sharing, others may benefit, but at the end of the day, we also benefit much more than keeping ourselves in our own office, doors closed, secret, not to share, to hide from our neighbor. So open doors, sharing, hearing, and learning. This is really the key principles of our work, nationally and internationally. And so this has been the driving force, in a way, to a journey that, in my case, now has involved more than 60 countries, a little bit all over the world. And it's amazing, it's the experience that we get from, for instance, recently I was in Germany for a training course on infrastructure asset management of urban water systems. And very soon afterwards, I was in Uganda giving the same course, basically the same course, the same. And it's amazing to see the differences, but the similarities and the arguments, and the similarities, of course, are many more than the differences. But to be with people with different background, with different experiences, with different motivations, with different challenges is wonderful. It's really a very rich experience that I have myself, but my colleagues as well, and it's fantastic. Well, so how was this international path? So as I commented a while ago, we started with Mozambique, started to think of this performance indices development. I further developed them in the scope of my own PhD thesis. I associated that with the development of levels of service inspired by the UK work. So Ofwat in UK has just launched the levels of service system, and I further developed that. I ended up with the by then International Water Supply Association, again by the hand, so to say, of Jaime Bel Batista. He was the head of the distribution division of IWSA, and he encouraged me and a German colleague, Wolfram Irner himself, to start working in the field of performance indicators within the association. These ended up with the IWA performance indicator systems that are nowadays a world reference used by many people all over. And this was later incorporated of the ISO standards 24510, 11, and 12. We also carried out an European research network called COST C18 that I chaired, about performance indicators of water supply, wastewater, and urban waste. And so this gave a lot of visibility to the work that we had started here in Portugal. Also from the project and research point of view, we participated in European projects such as the CareW on rehabilitation of water supply networks, KRS, rehabilitation of sewage networks, APUS, again on wastewater systems. And we started to evolve to asset management, because the performance indicators, they are a very important tool, but they are only important if they're going to be used to assist decision makers in some way. And well, managing the networks, or managing the urban water systems properly is really the value of using this type of indicators and this type of tool. So it was a natural evolution to go from the performance indicators to techniques and approaches around the infrastructure asset management. And when we use the term infrastructure asset management, infrastructure asset is as it were a single word. We're talking about the system management. We are talking about the management of our urban water systems, of the infrastructures. And infrastructure, I don't know the case in the US, but for us, infrastructure is not only the buried, is not only the vertical side of it, but is also the vertical, not only the horizontal, but the linear, but also the vertical infrastructures that we are addressing. So we developed here a project called AwareP that allowed us to develop an approach, a consolidated approach, software and guidance materials. We published two very comprehensive technical guides, one for water supply networks and the other one for wastewater networks. And from there, we decided then to launch the collaborative project, where we work in a kind of joint venture with a private holding. Jointly, we managed to capacitate and to work together with 30 utilities in the country. And they got competence in applying our approach and produce their own asset management plans based on this consolidated approach. We continue to work internationally with a research project that is the Trust, called the Trust, and I would encourage you to have a look at the Trust website, where there are many products available from the download section. So this Trust project finished very recently, last May, and we produced technical guides, again, software, an e-learning course, lots of products that I believe have some value. And we also work in a project for WERF, the Water Environmental Research Foundation, as you know, applying this AWARE approach and software in the case of Cincinnati. Sorry, of Gwinnett. No, not Cincinnati, sorry for that. Gwinnett, close by Atlanta. In the wastewater network, the gravity network of Gwinnett. And we developed some new modules of the software, of the AwareP software. We also naturally moved from the performance assessment group to the creation of a specialist group within IWA that is called the SAM, the Strategic Asset Management Specialist Group. This was created in 2007, and I chaired that group since then. Still telling you a little bit of the story of the international meetings. that have made a difference. As you can easily imagine, I have participated in many, well, conferences, workshops, seminars, in many places of the world. But I would highlight maybe three types of these meetings that seems to be particularly relevant in this context. And one is by no doubt about it is the Leicester conferences. Really, Brian Kobeck and Shun Ho really influenced us a lot, and I believe we have in some way influenced them in some way. But anyway, we received a lot of influence from Brian and from Shun Ho. Now, as you may know, working with Paul Bowles for 20 years or more in LA. And so my colleague Sergio Coelho and I, we attended the first Leicester conferences, and from then we really built a long professional contact and friendship with Brian Kobeck and Shun Ho. This made a difference for us. Another type of congress that I'd like to highlight is the IWA World Conferences. They really have influenced me a lot and are very inspiring. And I don't miss an IWA Congress. Well, since IWA was not yet IWA, it was still International Water Services Association. Back in 1988 in Brazil. The last type of conferences I'd like to mention are the LESAMs, the Leading Edge Conference on Strategic Asset Management, that are the biannual conferences organized by the SAM Specialist Group. The first one was here in Portugal in 2007. We had one in Miami, we had in Germany, we had in Sydney. We're going to have one this November in Yokohama, Japan, and then we'll be back to Europe, to Norway in 2017. This is about asset management, infrastructure asset management, strategic and tactical asset management. To finalize some sidewalks. Well, when Jaime finished his PhD, it was the time for me to start thinking of my own. And he encouraged me to start with real-time optimization. And I found it was a good topic, interesting topic. And so I decided to go out and have a look. For me, just reading papers is not enough. I really enjoy to see things working. So you may remember the very famous papers from Professor Frank Forsyth in UK, a very good work based by Carpentier and some other colleagues in France, some good work in Belgium. So I went out and went to the UK, went to Belgium, went later to Paris to see what was going on. And quite frankly, I was a bit disappointed because starting with the UK, I went there and well, after 2 hours of talk, I couldn't see, I was in a meeting, I couldn't see anything. I wanted to see the animal, you know, just to be there, to be in a room talking with people was not enough. I was really willing to see the animal. Well, at the end of insisting, after insisting and insisting and insisting, they ended telling me that the animal was not used at all. And they explained me some reasons, operational reasons, data related, well, all type of difficulties, practical difficulties. A very similar situation occurred in Paris. Again, the sophisticated real-time optimization module software and application that had been developed was not used. Was only used for marketing and for publicity. That was the only use it had. Later on in 87, when we went to Leicester, I think it was the first time we went to Leicester, Seventran has really a leading edge, really very good real-time optimization system, really very, very good. But even in that case, it was working the first time we went there. But 2 years later, again, it was no longer working. They started to have a lot of difficulties. They generated too much data, and they started having really problems, and it was abandoned. This made me think, is that if there are bottlenecks, if there are shortcomings, let me think of them, and let me try to invest my time on that prior to going directly to real-time optimization. And this is why we started, or this is when we started working more than 30 years ago in demand analysis and profiling. Understanding the behavior of the consumers, doing a lot of statistical work with regard to flow analysis and to producing typical profiles for the different types of users. So this gave already room to several PhD theses, to master theses. So this is a consolidated area of research of our team. Another area that we have been working for long, but had really an important evolution in last year, has to do with water losses and energy management. We work with water losses for long. I published myself a technical guide on water losses control and water losses management with other colleagues, not only myself, but with other colleagues from the team. But more recently, we started working in the water losses and energy efficiency management, integrated management of the two things. And we realized that the indicators that were normally used to control the efficiency in terms of energy, they were really not addressing the system behavior that the systems have. And so maybe, I don't know, 8 years ago, I think it was 2009, we published a first article. It was an oral presentation in a conference. In fact, it was not accepted for a journal because it was considered to be, I don't know, too simple, I believe. No fancy equations in it. I'm sorry for the sarcasm. So it was not accepted. It was just an oral presentation. But it was really where we started to think of an integrated way of looking at addressing the system's efficiency in terms of an integrated approach, and not the individual, not looking at the efficiency of the individual equipments only. So last year in 2014 we had a collaborative project on water losses and energy management where we applied this integrated approach. In the meantime, ITA in Spain, Enrique Cabrera, also developed work in parallel, and incidentally we found out that we were doing very similar work, well, because also we worked together for many years, and in a way we influence each other. And so we found out incidentally that we were doing very similar things without knowing from each other. And of course we merged efforts from then on and have been working together from then on. And he published a paper on this energy management system approach to energy management in an ASC journal. And we implemented this integrated approach last year in this collaborative project. In the beginning, I should say that the utilities were really rather skeptical, and even they were kind of criticizing, was saying, oh, you make us work hard for something that, well, is purely academic in the negative sense of it, kind of useless. We are making us waste time. And well, the fact is that it ended up working really well. And at the end of the project, when we asked for the balance for what went good, what went well, and what didn't go so well, so one of the things that were really at the top of the better rated aspects of the project was really this integrated approach to energy. They really like very much, and it was a very successful part of it. And of course, the analysis of the system, so the water distribution system analysis, is a fundamental part of this approach. Well, and so this is the story I have to share with you. And of course, feel free to come back to me and ask the questions on specific aspects that you find more interesting. Thank you very much, Walter. Bye-bye.